Hello, so what we're going to talk about right now is how to do complex number operations. Things like adding or subtracting. So the most basic form would be to take a complex number like 1 plus 2i and to add it to, let's say, 3 minus 5i. Now this is just a matter of like terms, really, real with real. So 1 plus 3, or 4, and then 2 plus a negative, or 2 minus 5i would be negative 3i. So I'm preferentially writing this grouped because that 4 minus 3i represents a complex number. Also, fundamentally, we end up with much the same thing. If we subtract, remember we're adding the opposite, and this is where the parentheses come in very handy, because this is really 1 plus 2i plus a negative 3 plus a positive 5i. That is, we distribute the negative. You can do this a couple different ways, but the idea is we're subtracting, and then we're subtracting the opposite. So we end up with 1 minus 3, or negative 2, 2 plus 5, or positive 7i. Wrap it up with a little bow or parentheses, and we're all set. Now, they can present this in weird ways, like you could have 3i plus 2 minus 7i, for instance, right? And it just means you're still combining like terms. So there's only one real number portion, that's a positive 2, and it's going to stay that way. 3 plus a negative 7 would be negative 4i. And that can be mixed around. But it's pretty straightforward, you're just combining like terms. Multiplying complex numbers. Multiplying complex numbers can happen in a couple of different ways. One way is to have two complex numbers that have real and imaginary portions. So for this, we just distribute. We need to take this times this, this times this, this times this, and this times this. Now remember, when you multiply complex numbers, you're going to get a complex number that is something of the form a plus bi out of it. And we'll see how in just a sec. So 2 times 4 is easy. That's 8. By the way, this is just FOIL. We've done this before. 2 times negative 5 is minus 10i. 3 times 4i is plus 12i. And last but not least, positive times negative is negative. 3 times 5 is 15i squared. And this is where remembering that I squared equals negative 1 is going to be incredibly important. Especially early on with these, when you're asked to show your work, which you will be, you should make sure that you are showing this work. Because what happens is you get 4, now negative 10i plus 12i, those becomes positive 2i, they are like terms, right? Minus, now this I squared is really a negative 1, so we have a negative 1. So what that does is it changes the sign, which means in the end we get 19 plus 2i, and that would be our final answer. So key thing, we're distributing, and I squared equals negative 1. Now you may see this in some slight different variations, but it's still the same idea. Let's say we take 4i times 6 minus, 8i, right? Well, you still distribute. 4 times 6 is 24i, right? 4i times a negative 8, so it's negative 32. I times I is I squared. We're still going to end up with, we start with a complex number times another. That's still a complex number. Technically 0 plus 4i, right? We don't need to worry about that, though. This negative 32i squared becomes a positive 32. That's still a positive 24i. So we're preferentially writing real number, then the imaginary, real portion, imaginary portion, altogether the complex number, okay? Now, dividing complex numbers is a little bit trickier. I'm not going to run through the why and wherefore, but essentially when we're doing this, we are going to be multiplying by something called the conjugate. Let's go 4 plus 5i, okay? So what we basically need to do is multiply by something such that we end up with this not being imaginary, okay? So we're going to multiply by the multiplicative inverse of this. Now, what happens is we end up multiplying by the conjugate, and now the notion here is when I do this, I'm not going to have a center term. So kind of like when I have x plus 3 times x minus 3, right? I get x squared minus 9 because the plus 3x and minus 3x cancel. Now in this case, this has an interesting effect, which you'll see here in just a sec. I'll leave that up there, that's fine, right? But this is kind of the template we're working with. Now, whatever I do to the bottom, I also have to do to the top, right? So here we go. 4 times 4 is 16, so I'm doing the denominator right now, right? 4 times a negative 5i is minus 20i plus 20i. So as promised, because I'm multiplying by what we call the conjugate. Now in terms of this, I'll explain more about the conjugate here in just a sec, but positive times a negative is negative. 5 times 5 is 25. And we know I squared, right? Now the numerator is going to be something too. It's going to be 8 minus 10i minus 12i plus 15i squared. It is very important to remember that I squared is equal to negative 1 in both cases. Now in this case, this cancels, so there's no imaginary part left. We get 16 minus a negative, or plus, 25. Now this becomes 8. Now that's going to be a negative 1, so that's going to be 8 minus 15, or negative 7. Remember, this I squared makes this a real number. Then minus 10 minus 12 is minus 22i. Now 16 plus 25 is actually a thing. That's 41. And we're dividing this whole thing by that. And to keep with keeping the real and imaginary parts separate.
Good morning, Lincoln. They will be working on the alarm system today, so if the lights or the sounds go off, this is not a test day. You don't have to go outside.
There you have it, folks. But in any event, we keep our real and our imaginary parts separated. Now, if you look at this carefully, if you remember way back when from the last video when I talked about graphing and then finding what's called the magnitude, remember, of a complex number. If we're looking at 4 plus 5i, that would graph out as a 4 here and a 5i here. Remember, that's the real and the imaginary portion. So it turns out that this, remember, is the hypotenuse. It's 4 squared plus 5 squared, right? So it turns out, if you look at this carefully, what is 4 squared? 16. What is 5 squared? 25. And we're adding them. Guaranteed every time. So one way to do this is to multiply the numerator by the conjugate and then multiply the bottom by the magnitude of the complex number, okay? Now this does also lead us to what the multiplicative inverse is, but don't worry about that too much. So some keywords here are conjugate and magnitude of a complex number, that is, which equals a squared plus b squared. So let me do another example, okay? So we'll do another more complicated example than a simpler one. So let's say we have 2 minus 3i being divided by 1 plus 7i. Now I know that 1 squared plus 7 squared is 49 plus 1, or 50, right? So I know that when I multiply by the conjugate, right, I'm going to get something over 50, okay? But then I need to multiply by the conjugate of that. So please bear in mind, if I multiply by 1 minus 7i, which is what I'm doing, 1 minus 7i, I know my answer is automatically going to be 50, so why don't I just go there? So whatever I get in the end is going to be something over 50 plus or minus something over 50i. So then it's a matter of distributing. 2 times 1 is 2. 2 times negative 7 negative 14i minus 3i, and then plus negative times negative 21i squared. So negative 14 minus 3, that's going to be minus 17i. 2, that is not a positive 21 because it's I squared is negative 1, so it becomes 2 minus 21, or negative 19. Right? So if you remember the magnitude thing, it can save you a little bit of grief, but you still have to multiply by the conjugate, at least in the numerator. So sometimes, and I don't know why this is confusing, but we'll take a look. What if I had 1 plus 3i and I was dividing it by 7i? Well, here what I'd want to do is I'd still want to multiply by the conjugate. So let's make a little space here. What is the conjugate of what I'm dividing by? Well, remember, this is the same as saying 0 plus 7i. So what's its conjugate? 0 minus 7i. Now, most people don't go that far. What they'll do is they'll say, oh, okay, 1 plus 3i, I'm going to multiply that by the conjugate of 7i, which is a negative 7i. Now, that means I'm multiplying this by a negative 7. So this is 49, negative 49, but then because the I squared is going to become a positive 49. And then the rest I just distribute. So 1 times negative 7 is negative 7i. 3 times negative 7 is negative 21i squared, which means this becomes a positive 21 over 49, real number portion first, and then minus 7i over 49, or 7 over 49i. And that, as they say, is that.